Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem gas station. So let us first start by understanding the problem statement. Given there are n gas stations along a circular route where the amount of gas at the ith gas station is gas of I. You have a car with unlimited gas tank and it costs cost of I of gas to travel from ith gas station to its next gas station, I plus 1th station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel along the circuit once in clockwise direction, otherwise return -1. If there exists a solution, it is guaranteed to be unique. So the crux of the problem is we are given with two integer arrays, gas and cost. Gas is nothing but the amount of gas is provided to us when we reach a gas station, and the cost is nothing but the cost or the gas we require to move from one gas station to another. And we have to find a gas station such that if we start at that gas station, we will be able to circuit back to that gas station. It is guaranteed there is only one such gas station, and if we are not able to find such gas station, we have to return -1. So let us understand by looking at the examples. So let me share the whiteboard. And now in the example 1, we are given with the gas 1, 2, 3, 4 and 5. Cost areas 3, 4, 5, 1, 2. So let us start from the 0th gas station. So at 0th gas station, we initially fill up one gas point, and then we require 3 gas points to move to the next station. The total will be -2. Since there is not enough gas to move to 1th station from 0th station, so we do not consider 0 as our answer. And then we move to the first station. Let us move to the first station. Initially, at first station, we fill up 2 points, and then we require 4 points to go to next station. Since we do not have enough gas, we cannot reach from 1 to second gas station. So 1 cannot be our answer. And let us start at second gas station. At second gas station, initially we fill 3 gas points and we require 5 gas points to move to the next station. So we are here also we are short in gas, so we don't have enough gas to move to third gas station from second gas station. So second gas station cannot be our answer. Now let's come to third gas station. In third gas station, initially we fill 4 gas points and we require 1 gas point to move to the next station. So since we have enough gas points to move to the next station, we go to fourth station with 3 gas points. And now we fill up 5 gas points and we require 2 gas points to move to the next position, which means 8 minus 2, 6. So here we still have 6 gas points. So 3 will be our answer. From 6 here again, let's see, 6 from 6, here from for 0 to 1, we require 3 gas points. So 6 minus 3 will be 3. And again here for 6 minus 4, okay, here it will be 3 minus 4, right? Sorry. So this will be, we have 6 points at 0, and at 0 we require how many gas points? 3 gas points. 6 minus 3 will be 3, and we fill up 1 gas point, so plus 1 equal to 4. We move here with 4 gas points. So 4 minus we require 4 gas points to reach next gas station, and we fill up 2. So we still have 2 gas points left. So we come here with 2 gas points, and at 2 we fill up 3 gas points, and we require 5 gas points to move to next gas station. So 5 minus 5, we will have 0 when we reach 3. So we are able to circuit back to 3 since, so that 3 will be our answer. And let us come to the second example here. So in second example, if you observe, we have gas 2, 3, 4 and cost area as 3, 4, 3. So what is the total gas we have? 2 plus 3 plus 4 equal to 9. And what is the total cost we have? 3 plus 4 plus 3. So here if we observe total gas, and this is total cost. Total gas is less than total cost. So the gas we have is less than the gas we need. So we will not be able to circuit back from whatever gas station we start. We will not be able to end up at that gas station because we don't have enough gas in the first place. So we return -1 in this case. So now that we have understood the problem, let us see how we can solve the problem. So the naive or the brute force way of solving the problem would be what we have did here, right? We start at each gas station and check if we can loop back or circuit back to that gas station. What will be the time complexity of this approach? We start at each gas station, we loop through all the gas stations. So it will be O of n square. So the naive or the brute force way of solving the problem is to start at each station and check circuit if we can circuit back or not. This approach will be O of n square. But can we optimize this approach? Let us see. Let us take another example. Let's say we have 5 gas stations, A, B, C, D, and E. Let's say we can reach from A gas station to B gas station and B gas station to C gas station, but we cannot reach from C gas station to D gas station. So what we can observe here, in the brute force way, what we do, if we fail, so we do not consider A, then we move to B and we again check if we can circuit from B to B. But if we observe, let's say we fail at C to D and we again started B. What is here? If we go from A to B, then we know we are carrying some positive or zero gas to B. Since we are going from A to B, we know we are carrying some positive or zero gas to B. So with this positive or zero gas, we are not able to reach from B to D. So we are saying we cannot go from C to D, so we are not going from B to D as well. So if we cannot go from A to D, we can say that we also cannot go from B to D and C to D as well, because we carry some positive or zero gas to go from A to B. With this positive or zero gas only, we are not able to go from B to C and C to D. Right, C to D we cannot go from this positive or with carrying this positive or zero gas. So without this positive or zero gas also, we will not be able to go from C to D. Hence we can say if we cannot go from B to D, we cannot go from A to D, then we can say we cannot go from B to D and C to D. So this is the catch in this problem. So what we can say now, if we fail at C to D, what we say? We start from D. We do not consider B and C as well. We start from D and we then check if we can go from D to E. And if we can go from D to E, then D will be our answer. If we cannot go from D to E, then E will be our answer, because here also, if we can go from D to E, we carry some positive or zero value. So with this positive or zero value, we should be able to circuit from E to A to B, and B to C. If we cannot go from here to here, then without this positive or zero value also, we cannot go from E to A. Since we know that we will have, if the solution is present, we will have a unique solution. So it will be either D or E. So if we can go from D to E, it will be D, or else it will be E. So this is the approach. I hope you understood the intuition behind the solution. So let us now code it up. So firstly, so let us first take how many gas stations we have, gas dot length, and then what we have to check if we can we can complete a circuit. So for that, we have to check total gas. Let's compute the total gas and total cost. So first, int I equal to 0, I less than n, I plus plus, and total gas plus equal to gas of I, and total cost plus equal to cost of I. So now we check if total gas is less than total cost. In this case, we know we cannot circuit back, so we return -1. Now we know we can circuit. We can complete the circuit. Now what we do? We have a running gas value, and we also should have the starting position. This will be our result as well. So now we again loop on the gas stations, and we now what we do here, we increment the gas. So what will be the gas now? The gas will be, we add the gas and we subtract the cost. And now we have to check if running gas of I is, the running gas only. So the running gas is less than 0. If less than 0, we know we cannot start from this position. So we update the starting position to be I plus 1. And now we finally return the starting position. Let us run the code and see if passes all the test cases. Okay, we are getting the output 4 and we want 3. So where did we do wrong? Yes, here we have to reset the gas value. Whenever we know we have less gas value, we have to reset and we have to update the starting position. So it got accepted for the sample test. Let us submit it. It passes all the test cases. Let us look at the time and space complexity. Since we are iterating over all the gas stations once, the time complexity of the optimized approach will be O of n. And since we are not using any external space, we are only using the constant variables, the space complexity will be O of 1. So in brief, first we are checking if we can circuit back or not. How we are checking that? So we are calculating the total gas and total cost. If total gas is less than total cost, we cannot circuit back. So we return -1. And if we can circuit, then we are calculating running gas. We are keeping track of running gas and starting position. We iterate over each gas station and we keep track of the running gas. If running gas gets less than 0, then we are resetting the running gas and updating the starting position. Because we know if we are not able to go from the starting position to certain position, we cannot go from the middle positions as well. So we update the starting position to be I plus 1, and finally we return the starting position. So I hope you have understood today's problem. If you did understood, make sure you like this video, and If you have any doubts, feel free to comment down below. I will try to answer as many comments as possible, and do subscribe to the channel for more daily videos. Thanks for watching. Bye.